In the name of God, this is Reza Ria Samani with title Montreal, Building a Safe Place for Cyclists and Pedestrians. After New York, San Francisco, and Vancouver, this is Montreal, the fourth best city in North America having a green and sustainable transportation. Having said that, looking over the years, the major fraction of victims for pedestrian and cyclist collision, as well as the total count, has always been noticeable. In this research, the following objectives will be studied to achieve practical plans. First and foremost, a collision severity model will be built to assess the degree of risk for non-motorized collisions. In addition, the second and third objectives try to study non-motorized collisions through other perspectives. For example, the second one tries to investigate the association between collision density and public transportation accessibility index as an indicator of walking and cycling environment. Next, the third one tries to characterize the crossing facility degree of protection by identifying the volume of pedestrians and cyclists. And finally, the statistical significance of mentioned factors to explain non-motorized collisions will be studied. Through the coming slides, the perspectives, approaches, and the methodology of the research using the following datasets will be discussed. Well, detailed reports of collisions have been gathered by Montreal Mobility Department since 2012 to 2019. As you can see, the exact time and location of each accident report is available, as well as various attributes in describing the accident scene. For example, road surface, a speed limit, road category, and so on, which each of these will have various categories as well, enabling us to model the collision severity according to our first objective. Here the table shows sample data, and it could be demonstrated as a one-hot encoding format as well. Having considered the dataset, K-mode clustering algorithm seems so useful to give us informative clusters regarding characteristics of accidents given their location and similar features. More cities hotspots regarding collision severity is expected to be investigated. In addition, as long as the dataset is a categorical one, decision tree seems so logical to be implemented. We could take advantage of its tangible rules. And finally, other classifiers such as KNN could be also tested and then be compared with other methods. Through the second and third objectives, the perspective of the research will turn into city segments. As the figure 4 shows, Public Transportation Accessibility Index has been calculated for each city segment. It is going to be one of our independent variables, as public transport could be considered as producer and attractor of non-motorized trips. For the third objective, two datasets are considered. First, the left-hand side figure shows the location of intersection counters, giving us the volume of pedestrian and cyclist traffics. The second figure, the right-hand side, shows the quantity and the location of pedestrian crossing lights. The city segment perspective have been applied to severity density as well. All the mentioned datasets have been joined and aggregated in each DAU or dissemination area units. The density of severity is also available. Let's go modeling. As we are dealing with numeric variables, a spatial regression model seems logical to find the relation between PTAI, crossing facilities, as well as the volume of pedestrians and cyclists. In the future, dynamic analysis of evolution of collisions for non-motorized users, as well as microeconometric structural utility calibration of transit choices, is expected to be studied.